In this lesson, we'll learn how to design more complex parts in TinkerCAD. I'll focus on the design process, including how to break down complex parts into simple shapes and how to create patterns using features like grouping, mirroring, and alignment. These are very important skills when doing 3D modeling. When designing a part, we usually follow these steps. The first step is decomposition. Complex parts can seem confusing, but by breaking them down into simple geometric shapes, it allows us to see more clearly how to model them. The second step is to adjust the size. Once the shapes have been broken down, we need to resize each shape to suit our actual needs. By precisely sizing the part, we can ensure that the part fits with the rest of the part. The third step is to align the shapes. The alignment operation is very important as it ensures that the different shapes are in the correct position in relation to each other. With the Align tool, we can make multiple shapes fit neatly together to avoid misalignment during design. The fourth step is grouping. After the basic shapes have been adjusted, we can combine multiple shapes into a whole. TinkerCAD provides a group function, which helps us to combine multiple elements into a single object, so that it is easy to manipulate and adjust the shapes in the following steps. At the heart of these steps is breaking down complex parts into simple elements, which not only simplifies the design process, but also improves the manufacturability of the part. With TinkerCAD's Simple Shapes tool, we can easily practice this skill and step through more complex designs. There are 4 main basic operations for designing parts in TinkerCAD: add, cut, pattern, and mirror. I will explain each of these operations below. Adding is the process of adding shapes to a part. In TinkerCAD, you can add new elements to your design by selecting the base shape and dragging it to the work plane. Cutting is the process of removing a shape from a part. For example, when you want to dig a hole in a cube, you can cut it using the hole shape. Cutting helps you to accurately remove unwanted parts to create the desired shape. By combining tools such as duplicate, rotate, and align, you can easily achieve the effects of repeating arrangements, symmetry, and regular patterns. By mastering these techniques, you can create a variety of intricate patterns in your designs, which will increase design efficiency and creativity. The mirror function flips a part of the design so that it appears on the opposite side. This is especially useful for symmetrical designs and prevents us from repeating the same operation manually. Now we begin a practical exercise by designing a bracket for a robot chassis. The chassis is usually the basic framework of the robot, to which all other parts depend. First, we break down the chassis into simple geometric shapes. You can break down the chassis into several rectangles and cylinders. By combining different shapes, you can easily create a complex chassis structure. Remember to use calipers to measure each part according to what you learned in class. You will need to adjust the size of each shape based on the measurements to make sure they will fit together correctly. Once the shapes are adjusted and aligned, they can be grouped. TinkerCAD's grouping feature will help you combine these simple shapes into a complete design. Let's move on to the next exercise and design a simple gearbox. The gearbox is a key component of the robot and is responsible for controlling the motion of the robot. When designing a gearbox, we follow the same steps of decomposing, adjusting, aligning, and grouping. The gearbox is designed as several simple cubes and cylinders, which are combined into a complete part by means of precise positions and dimensions. Use calipers or the ruler tool in TinkerCAD to make sure that all parts are dimensionally realistic. During the design process, ensure that all components are aligned so that the parts can be accurately assembled together. Finally, group these shapes to form the final gearbox model. Next, we will design a wheel for a robot. The design of the wheel may seem simple, but it involves combining several shapes. Consider breaking down the wheel into a circle, a pentagram, and a cylinder. Resize these shapes to the correct size and use the Align tool to make them symmetrical. Once the design is complete, make sure you group all the shapes together to form a complete model of the wheel. Finally, let's tackle a more complex design: casters. Casters are often made up of several complex components, so the design requires a higher degree of precision. Depending on the actual requirements, casters can consist of several rings, cylinders, and connecting components. You can break down the design according to these components. Using calipers or a measuring tool, make sure all parts are the right size and align those parts. After completing the shape adjustment and alignment, all parts are grouped together to finalize a complete caster design. Today, we learned how to design parts in TinkerCAD with a few examples. We explained the design process, including how to break down complex parts into simple shapes, how to resize, align shapes, and group them. We also learned the basic operations in TinkerCAD: adding, cutting, and mirroring. These operations are key skills in the design process, and once mastered, you will be able to design more complex parts in TinkerCAD, laying a solid foundation for future robot design. Thank you for your participation. That's all for today's class. If you have any questions, please feel free to ask.